Hello, I'm Anna Tapper, and welcome to the session on teaching fractions for understanding. When teachers are asked which areas of primary mathematics pupils struggle with most, fractions, including decimals and percentages, is almost always the answer. But why is this? What is it about fractions that makes it such a difficult subject to teach? Well, fractions are not like natural numbers. They can have more than one value. So, for example, a quarter is a number on a number line, which is always less than 1, but a quarter of 20 is 5. Fractions are relational, so the size of the fraction depends on the size of the whole. 1/4 of 20 is not the same as 1/4 of 60. Fractions do not follow the usual rules of arithmetic. There's a common misconception that develops from earlier in the mathematics curriculum that when we multiply a number, the product will always be bigger than either of the factors. However, this rule doesn't work when working with fractions. The larger numbers represent smaller values. This is a common source of misconceptions and errors when working with fractions. There's specific terminology of fractions that does not relate to any other areas of learning in maths, and words like a quarter instead of a fourth also cause confusion. And very often, fraction symbols are introduced without an understanding of what the numerator or denominator actually means. Pizzas and cakes have a lot to answer for. This is the most common representation of fractions in primary schools, and often, when faced with tricky questions, children resort to drawing inaccurate circles. However, a pizza or cake only represents a fraction of a whole, and normally only equal fractions of a whole, leading to the misconception that this is only what fractions are. Here is another representation of a fraction showing unequal parts. If Europe is the whole, then what is a part? The language of fractions can first be introduced through wholes and parts. We may ask, if Europe is a whole and Portugal is a part, can you find a part that is greater than Portugal? This representation shows that the whole is not always 1. The whole here are the swans, and the white swans may be a part. Evidence of teaching fractions suggests that using a number line is an important representation to introduce in lower key stage 2, so that children recognise that a fraction is an actual value, and later on they can relate this knowledge to decimal and percentage equivalents. Most children may be able to find a quarter on this number line. But what about this one? Do we mean a quarter of the line, or a quarter as in 0.25? This is a great tool to use to explore and address different meanings of fractions. Using different representations of fractions, including non-examples, is a great way to develop discussion around fractions and secure understanding. I wonder what misconceptions you think pupils may have here. Some pupils may say they cannot identify the fraction as the parts are not equal. They don't look the same. Others may say that it's a half because they're looking at the two parts of the rectangle separately. Either way, a great starting point for a discussion on how equal parts may look different. Pattern blocks are another effective way to explore parts and wholes, including equivalent fractions. You can get virtual ones on MathSpot if you don't have the actual manipulatives in your class. For example, you may ask, if the hexagon is a whole, what is a trapezium? What about the triangle? How many of the triangles would you need to make the trapezium? And so on. You may have looked at my other short recorded sessions on using quiz and air rods, but again, they're a great way to explore fractions, and particularly equivalent fractions or mixed number fractions. We've identified that language is really important in maths. It allows pupils to communicate challenging mathematical ideas clearly, and it's no different in fractions. However, the language is specific to fractions only. Terms like numerator, denominator, and vinculum need explaining, not just naming. Making terms like unit fraction and non-unit fraction explicit also helps pupils to share their ideas and reason mathematically. Another common misconception is that the larger the denominator, the larger the fraction. Using a fractions rule and the language of inequalities can really help here. You might ask, can you find a fraction that's equal to 1/3? What do you notice about the numerator and the denominator? What do you notice about the size of the parts? Can you find a fraction that's smaller than 1/3? What do you notice about the denominator? And so on. A great way to expand this discussion is to write an inequality using fractions and ask pupils to prove it in 3 different ways. It's also a really useful assessment tool. Have a look at these 3 questions here. Which one do you think pupils would find more challenging? I wonder why. I think C, because it involves finding an equivalent fraction. However, if children have done lots of the preliminary work we've just looked at using fraction rules, quiz and error rods, and pattern blocks, then these type of questions become much more manageable. When we teach addition or subtraction of fractions that involve finding equivalents, using bar models is a clear and effective way to represent the concept. Here is the original calculation represented. And here is a calculation represented through equivalent fraction of 6ths. Unfortunately, many children return back to those cakes and pizzas, and their models are not as effective as it is much harder to split a circle into even parts. Encouraging the use of bar models for fractions aids understanding. Here we're looking at multiplying fractions by whole numbers. If I was teaching procedurally, I would tell pupils to multiply the numerator by the multiplier. However, I want them to understand why this works, and a bar model shows this concept really clearly. Here I've used a single bar. However, here you can see I've used 3 bars. Each way represents multiplying a fraction by an integer. But what about multiplying fractions by fractions? This is trickier to represent, and here an area model is really useful. You can see that the model's been split into quarters. Then the model shows 1/3 of 1/4, which is 1/12. Again, I could teach procedurally. However, a tutee would not know what they're doing or why. The model helps to explain this and also explain why the answer is smaller when you multiply fractions. This is another example of using non-unit fractions. The calculation is 2/3 multiplied by 3/4. This model shows the area model split into quarters, and the 3/4 is shaded. Then the red shading shows 2/3 of the 3/4, which is 6/12, or 1/2. When dividing fractions by integers, it's important for children to understand what they are doing. The procedure would be to multiply the denominator by the divisor. But why does that work? Using bar models to show the division of the fraction helps here. Teaching pupils to translate circular models into bar models is useful too. Here they can see how each quarter has been divided into 3. This is an example from a Maths No Problem textbook, and it's a great one to use with pupils who struggle to understand how division of fractions works. Here we could say that 3/4 divided by 2 is the same as 1/2 of 3/4, which we know is 1/2 multiplied by 3/4. Explaining division through equivalence helps pupils to make this link between the different areas of learning and gives them an alternative way to solve the calculation. Finally, I wanted to draw your attention to the materials on the NCETM. The primary mastery materials and the exemplification of the Ready to Progress criteria have lots of information about how to teach fractions conceptually for all year groups. They also include the key language to use, sentence stems, representations, and example questions. I'd really recommend that you look at those when planning your next fraction unit. Thank you.